So here we need to show that the points A, B, and C form the vertices of a right-angled triangle. And after we verified it, we need to also find out the length of the hypotenuse as well as the area of the triangle. So let us begin. So we'll begin this problem by considering a triangle. This is not a right-angled triangle because we do not know which side is going to constitute the hypotenuse. So let's first begin by naming the vertices. So we have the triangle with vertices A, B, and C. It's given to us that A has the coordinate 2, -2. B has the coordinate -2, +1. And C has the coordinate 5, 2. Fine. Now what we'll do, we'll try to find out the length of each of the sides of the triangle. For this, we'll take the help of the distance formula. So here we have the points A and points B. So A has the coordinate x1, y1 and B has x2, y2. Now we're going to join the 2 points A and B with the help of a straight line. Then the distance between point A and B is given by this particular formula. So AB will be simply equals to, take the square root. Underneath the square root, first we will take the square of the difference of the x coordinate and then add it to the square of the difference of the y coordinate. So let's try to employ this particular formula here. So we have AB. So AB will then be equals to, we'll take the square root. Underneath the square root, what we'll do, we'll first take the difference of the x coordinate. So we'll start with the x coordinate of B, so that's -2. And from here, we'll subtract the x coordinate of A, so that's simply 2. So we have -2 minus 2 and then square this result. And then we are going to add it to the difference of the y coordinate. So we'll start with the y coordinate of B, so that's 1, and from it subtract the y coordinate of A. We have -2 here. Since we're subtracting -2, so we're going to get +2, and then we're going to square this result. So this will be equals to, so we have square root of the -2, so that's going to be -4. Square of it is going to give us +16. This is added to 2 plus 1, so that's 3. 3 squared is going to be 9. So 16 plus 9, that's 25. So square root of 25 comes out to be 5. Now AB has a length of 5 units. Now we'll try to find out the value of BC. So BC is going to be equals to, we'll take the square root. Underneath the square root we have, first we'll take the difference of the x coordinate. So here we have 5 minus of -2. So that means we have +7 squared. Then we are going to add it to the difference of the y coordinates. We have 2 minus 1, so that's 1, and then we square it. So this will be equals to square root of 7. 7 squared, that's 49. 49 plus 1, that's going to be 50. So we have square root of 50, which is simply 5 times square root of 2. Now we'll find out the length CA. So CA is going to be equals to, we'll take the square root. Underneath the square root, we take the difference of the x coordinate. So we have 2 minus 5, so that's going to be -3. So we take -3 squared. Added to, so we have the difference of the y coordinate, -2 minus 2, so that's going to be -4. So -4 whole squared, and this is going to give us a value equals to 5. Fine. Now clearly what we'll do, we'll square each of the sides. So let's do square AB. So AB squared is going to be 25. BC squared is going to be equals to 50. And CA squared, that's going to be equals to 25. Now clearly we see that BC squared equals to AB squared plus CA squared. And this is the criterion for the Pythagoras theorem. So that means we have successfully showed that ABC is a right angle triangle. Now let's redraw the triangle. So here we have a right angle triangle. So it is right angled at angle A because BC is the longest side and it's going to be the hypotenuse of this particular triangle. Yeah, we have proved the first part. Our next task will be to find out the length of the hypotenuse. Since BC is the hypotenuse, its length is 5 times square root of 2. So that's found. Now we'll go to the area of the rectangle. To find out the area of the rectangle, what we need is the base, the length of the base, AC. So AC we've obtained as 5 units, and the length of the altitude here will be AB. So that's 5 units as well. So therefore, area of our triangle ABC, which is given by the formula half times the base AC times the altitude, so that's AB. So we have half multiplied to 5 times 5, so that's simply going to be 25 over 2 square units. So that's going to be the area of a triangle.